Hey buddy, in this video, we're going to talk about how to divide fractions by whole numbers. So when you're introducing this concept to your students, remember that there's two different ways of thinking about division. There's sharing division, where you take a certain amount and split it up into a specified number of groups, and then you try to figure out how much is in each group. So an example of this would be if you had a class of 20 children and you wanted to divide it up into 4 teams. So you have a specific number of groups and you're asked how many children are on each team. And you could figure this out by dividing up these children equally into the teams. And eventually you would figure out that there's 5 children on each team. So the answer would be that there's 5 children. Measurement division, on the other hand, is when you have an amount and you're splitting them up into a specified size of group, and you want to figure out how many groups there are. So this would be like if you had a class of 20 children and you were dividing them up into teams of 4 people each, and you are trying to figure out how many teams are there. So again, the answer is still 5 because you're doing 20 divided by 4. But the situation that it's modeling is very different. So when you're introducing the division of fractions and whole numbers, if you're dividing something by a whole number, it's easiest if you think about it with sharing division. If you're dividing something by a fraction, it's easiest if you think about it as measurement division. So let's model these on a number line to show what this would look like. Okay, so if we had 1/2 and we wanted to divide it by 3, I would first find the distance 1/2. So if I take the distance from 0 to 1, split it in half, that's this mark right here. So I want to take this amount right here, and I want to divide it into 3 equal-sized pieces. So I say, okay, well, let's just take this distance, split it up into 3 equal-sized pieces. So this number right here is what 1/2 divided by 3 is. So now the question is, well, what is that number? So I took the distance between 0 and 1/2, split it up into 3 pieces. And if I extend this to the number 1, and I divide the other half into 3 pieces, because this half is the same distance as 0 to 1/2, then the amount of this size of pieces that I have between 0 and 1 is 1, 2, 3, 4, 5, 6. So 1/2 divided by 3 equals 1/6. And this is how you would think about division in a sharing way, because I'm taking the distance 1/2 and I'm splitting it specifically into 3 equal-sized pieces. And I'm looking at how big one of those pieces is. Now, if you're dividing 3 by 1/2, it would be easier if you think about it as measurement division. So I'd say, okay, I'm going to take the distance between 0 and 3, and rather than dividing it into a half of a group, which is kind of confusing for students to think about, you can think about it as I'm trying to take the number 3 and I want to see how many halves I can make out of 3. So I'm making groups of 1/2 and I want to see how many there are. So I'd say, okay, well, I have enough to make one group of 1/2. I have enough to make 2 groups, 3 groups, 4 groups, 5 groups, and 6 groups. And so 3 divided by 1/2 equals 6, because if I take the distance 3 and I divide it up into groups of size 1/2, I have 6 groups altogether. And that's the way that you can think about dividing by a fraction using measurement division. So let's look really quick what this would look like in an area model context. So same numbers that we had before, but instead we're going to represent it with an area model instead of a number line model. Okay, so if I have 1/2 divided by 3, the way that I'm going to think about this is I'm going to have a half of a circle or a square or whatever type of shape you want to use. And I'm going to divide it equally into 3 pieces. And one of those pieces is going to be my answer. So I just need to figure out how big that piece is. And if I split the other half into the same size of pieces, it looks like this is 1/6. If I do the other one where I have 3 divided by 1/2, I don't want to divide this into a half of a group because that concept is kind of hard to think about. Instead, I'm going to say, okay, how many halves or groups of size 1/2 can I make out of 3 wholes? And the answer to that is I can make 1, 2, 3, 4, 5, 6 groups of 1/2. And so that means 3 divided by 1/2 equals 6. Another way you can introduce this to your students is with meaningful word problems. So if Maggie has 2/5 of a cake left over from her birthday and she shares it equally with 2 other friends, how much cake does each person get? So we could model this with an area model. So let's say we have fifths, kind of like this. Maggie has 2/5 of them, and she wants to share it equally with 2 other friends. So basically what we're doing here is we're doing 2/5 and we're dividing it by 3 because there's Maggie and her 2 other friends. And to solve this, we could say, okay, well, if we take this piece of cake and give 1 to each person, so Maggie gets this piece, her other 2 friends get those other 2 pieces. And then if we take this cake or this piece and split it up equally, it looks like Maggie gets 2 little blue pieces, but how big are those pieces? Since we split up our pieces of cake into thirds, we should probably cut these empty pieces up into thirds as well so we can see how many pieces are in a whole. And when we do that, we get 15 pieces in a whole. Maggie gets 2 of them. So 2/5 divided by 3 equals 2/15. Now, you could also do a whole number divided by a fraction, like in this word problem. So we have Samuel is painting fence posts, and it takes 1/12 of a can of paint to cover each fence post. How many posts can he paint if he has 7 cans of paint? So if I was one of your students solving this, maybe I might draw a picture of these 7 cans of paint. So here's 3, 4, 5, 6, 7. And I want to know how much paint it will take or how many fence posts I can paint with these cans of paint. So it says that it takes 1/12 of a can to cover each fence post. So if I split up this can of paint into fourths and then thirds, basically this amount right here is the amount I need for 1 fence post. And that means that the first can of paint can be used to paint 12 fence posts. Then the second one can also be used to paint 12 fence posts, and so on and so forth. And depending on how good your students are with their multiplication tables, they may think of this as 12 times 7, which would give them the answer of 84. And so basically, if we do 7 divided by 1/12, this equals 84. And this would be an example of a measurement division word problem. Once your students are understanding word problems like this, you can extend it to make it a little bit more challenging. Like, for example, we could say now Samuel is painting doors, and each door takes 2/7 of a can of paint. If he has 3 cans of paint, how many doors can he paint? So we could say, okay, well, if each door takes 2/7 of a can of paint, then he can paint 1 door. Then he can paint another door. So that's 2 doors so far. Then 3 doors. And then the 4th door is going to use up this part of the can of paint, and then it will also use up part of this one. Then our 5th door can be painted. I'm going to kind of repeat my colors because I'm running out of colors, but there's our 6th door and our 7th door. And then our 8th door and our 9th door and our 10th door. And then we have enough paint to cover a half of a door. And so our answer to this, so we were basically doing 3 divided by 2/7. And our answer to this is that 3 divided by 2/7 equals 10 doors that he can paint. And he can paint a half of a door because we have enough paint for him to cover half of a door because we have 1/7 left and it takes 2/7 to paint the whole door. And then you can make it even more challenging and you can say, okay, well, what if he's painting desks and each desk takes 3/5 of a can of paint? How many cans of paint or how many desks can he paint? So we might say, okay, well, 3/5 of a can of paint, that would paint 1 desk. Then he could paint another desk with the rest of that can and then part of the second can. Then he could paint a third desk, and a fourth desk would take the rest of that can of paint and 2/5 of this can of paint. And then I think what number are we on? 1, 2, 3, 4. Our fifth door or desk could be painted with the rest of that can of paint. And then we could say that our sixth desk could be painted with this. And then we need to look at this and say, okay, well, we have 2/5 left. And how much of a desk will that be able to paint? So a desk takes 3/5 and we only have 2/5. And so that means the amount of the desk that will be painted is 2/3 because it usually takes 3 of these rectangles to paint a full desk and we only have 2 of them. And so our answer to 4 cans of paint divided into groups of 3/5 is that we have 1, 2, 3, 4, 5, 6 desks, and then 2/3 of a desk. So 4 divided by 3/5 equals 6 and 2/3. And then once you've gone through several different word problems like this, you can bring it all together by summarizing all of the word problems on, let's say, like an equation board. And you can let your students look at the problems to see if they notice any patterns. So in the first word problem where Maggie had 2/5 of a cake divided between 3 people, we found that that equaled 2/15. When we had 7 cans of paint divided equally into, I think we actually divided it by something different, but you could do a word problem where you have 7 cans of paint divided into groups of 1/2, which would give you the answer 14. And then the 3 divided by 2/7 was when Samuel was painting the doors, where each door took 2/7 of a can of paint, and we had 3 cans of paint. And the answer that we got was 10.5. But if you convert that to an improper fraction, it makes it a little bit easier for the students to see the pattern between the numbers. Same thing if you have 4 divided by 3/5, like when Samuel was painting the desks. We got 6 and 2/3, but it will be easier if you think about it as 20/3. And once you have all of these equations summarized on your equation board, the students will start to notice different patterns. Like they might notice that the 21 is 3 times 7, or the 20 is 5 times 4, or sorry, 4 times 5. The 14 is 7 times 2. And then this 2, they might be a little bit confused and be like, like what was that 2 multiplied by? But you can remind them that the number 3 is can be written as a fraction as writing it 3/1 because it's 3 wholes. And that pattern is consistent because 2 times 1 does equal 2. Then you can show them, or they might notice that the denominator is determined by the top of the second fraction because 2 was the numerator of the fraction we were dividing by, and that's the denominator. In this case, we had a 3, and the denominator was a 3 in our answer. And here we had a 1, and again, because 14 can be written as a fraction, that's the denominator there as well. However, that's not the case in this one because the denominator was 15 here, and this numerator was 3. And so they might realize, oh, actually, you have to multiply this by this to get the denominator. And that would still be consistent in all of these answers because these are all over 1, and 1 times 2 does equal 2. 1 times 1 equals 1, and 1 times 3 equals 3. So you can help your students notice these patterns, but it will be more meaningful for them if you do it after they've solved meaningful word problems about it. So those are some ways that you can introduce the idea of dividing fractions by whole numbers and vice versa. If you have any questions, let me know.